So students, in the last class we were discussing about the elements and compounds, like about the matter, and once just we revise, matter is anything that has a mass and occupy the space is called as a matter. And matter can be classified in two ways. One is based on the physical properties and the second one is based on the chemical composition, right? And based on the physical properties, we can classify the matter into solids, liquids and gases, right? Based on the chemical composition, they are classified into two substances. One are called the pure substances and second one are called the mixtures, right? Pure substances means what? Which are made up of one kind of substances are called pure substances, right? And a pure substance, again they are classified into two types, like elements and compounds. Elements and compounds. And other one are what? Mixtures. Mixtures are like impure. Instead of calling it them as an impure, we then call it as a mixtures. Again, mixtures are classified into two types. One are called hetero and second is called homogeneous, right? So now we keep the second classification, that is mixtures, aside. Now we are discussing about the pure substances, right? The pure substances, elements and compounds. Elements means what? Molecules made up of identical atoms are called elements, and molecules made up of different atoms or different elements are called the compounds, right? So this we discussed in the last class, and also I think we discussed about some important elements. So students, already I give you that there are 118 elements are there, total 118 elements. So total 118 elements are there, and these elements start from hydrogen, and I said you to read 20 elements, I think so, like hydrogen, helium, lithium, beryllium, boron, like this. I give the atomic numbers 1 to 20 and their elements, their symbols and their valencies. This I gave in the last class, right? So today students, actually according to our syllabus, so here we can see right, you can see here the classification of matter. Matter is classified into two types, based on the physical classification and second based on the chemical composition. Based on the physical state, mainly solids, liquids, gases, this we will learn later, and chemical composition, pure and mixtures. So pure, elements and compounds, mixtures, homogeneous and heterogeneous. Again, elements are classified into metals, non-metals, metalloids and noble gases. Now this we are going to discuss one by one, right? Now in the next class what we discussed is, I gave some 20 elements to you, right? So hydrogen, helium, lithium, beryllium, boron, carbon and so on I have given, right? So here there are some definitions. These definitions also are given to you. Pure substance means what? Which are made up of same kind of substance are called as a pure substances, and mixtures that are made up of different kind of substances are called as a mixtures. And pure substance examples of what? Elements and compounds. Elements means what? Which are made up of identical atoms are called elements. Identical means what? Same. And like example for elements, all this we can give, like hydrogen, helium, lithium, beryllium, boron, what I give, those are comes under the elements. And compound means what? The molecules made up of two or more different elements are called as a compounds, like carbon dioxide, sodium, chloride. This all I give. So here these are the some elements names, 20 elements I have given to you, and here name, how the name symbols are given, this already I discussed in the previous class, but once again let's see here. So here 1 to 20 elements, this already done, and I said you how to give the symbols for the elements. How were the symbols were given? Like hydrogen, the element is starting with H, so the symbol is given as H. And next you see the helium. Helium is also starting with H, but H already is given to the hydrogen. So first two letters I have taken He as a symbol for helium. And you write the symbol of any element consists of two letters, then first letter should be in capital, second should be in small. And here see students here by giving the names, means the symbols of the elements. So they have taken into consideration not only like English, but they have taken some different names, means different strategies they have followed in giving the names. Like for example, students, if you see the sodium, sodium, and it is starting with H, but its symbol is Na. Its symbol is Na. Why it is Na is given? Because its Latin name is natrium. Okay, what it is? Natrium. Okay, so here the symbol of sodium is taken based on their Latin name, right? Similarly, potassium is there, potassium, right? So here the potassium symbol is given as K, but nowhere you can find K in the potassium. Here this also is given based on the Latin name, so that is called as a kalium. Okay, kalium, right? So like this, the names, the symbols of the elements given based on their Latin names, right? Only Latin names? No. Here the names of the elements also given based on different strategies. Like as you know, some elements names are given based on the planets. Okay, so like Mercury. Mercury, this is a planet, right? Plutonium, of course, it was not. Now it is not a planet, but previously it was considered as a and a planet. Now next you see the uranium. Okay, Uranus. So here these some names of the elements is given based on their planets names, and some elements are given based on the scientist names also, like Rutherfordium, Einsteinium, right? So here there are some elements out there like Rutherfordium. The element number is atomic number is 104. 104 element name is Rutherfordium. So Rutherfordium is given on the honor of the scientist called Rutherford, right? So Rutherfordium. Similarly, you can see the next Einsteinium. Okay, so Einstein, based on after the name of the scientist Einstein, the name of that element is given as Einstein. Like this, different methods they are strategies they followed in giving the names of the elements. So we'll learn one by one, slowly in this one, right? So now, so here you can see here there are some elements name in English, name in language, then other than English, and a symbol. So lithium, this is English only. So Li, sodium, see Latin name is natrium, natrium. So that's what here the symbol is given as Na, right? Now similarly you can see the here magnesium. Okay, now see potassium. Potassium symbol is K. So here it's given after the name of the kalium. Okay, kalium. So that is K. Similarly, you can see iron. Iron name is given as a ferrum based on the Latin name, and the symbol is given as Fe. Similarly, copper. Copper is symbol is given as Cu. Okay, because in the Latin name is cuprum. It's starting with the Cu. So here these also you have to learn, students. So important element. These all are the some important elements you have to learn, and you should know their symbols and their based on what the symbols were given to this one, right? Now then come to the next one. So here you can see these are the some other elements. Okay, did you get the material to you? These are all present in the material, right? So see here, silver. Silver is what? Argentum, and this is also Latin name. Tin, stannum, gold, aurum, mercury, hydrogenum. So these are the based on the Latin name the symbols are given. Okay, hydrogenum. Okay, Hy. So it is starting with H, and here a prominent letter G. So it is taken Hg. Aurum you see gold, Au. So here Au. Right. Similarly, tin, stannum, Sn, and silver, argentum, Ag. like copper, this already we discussed, right? So these are the some of the elements, how to give the names. Right. So these are similarly lead Latin name is plumbum, the symbol is Pb. Next tungsten is wolfram, and it is W. So these are the important elements you need to learn, means you have to by heart this one, right? So here this is about the elements, and elements are classified into metals, okay, and you know metalloids, next non-metals, and you know noble gases, like this. So elements are classified in different ways, like metals, metalloids, non-metals, and noble gases. Now let us see what are the metals. Metals means, you know, but I think you might have already studied some properties of the metals in the lower classes. Like metals, some important properties if you see, metals are, you know, sonorous. What is with the sonorous? Sonorous means what? Which can make a loud sound. They are called metals. For example, take some metal, and if you drop this metal on the ground, then you can see a louder sound, okay. Instead of if you take like paste, like plastic one, pen, pencil, if you drop, you don't listen that much sound, right? So they are called as a sonorous, okay. And generally metals are lustrous. What is the lustrous? Shiny. Lustrous means what? They are shiny. Generally when you take the freshly cut metal, it will shine, you know, like for example, you know, the silver, gold, they shine. Even you can take the iron also. When you purchase the iron, like you know, iron nails from the shop, how it looks like a shiny. You know, the aluminum also, aluminum foils, you know, that it is used in the wrapping the food, okay, so packing the food, so that aluminum is also shiny. Generally metals are lustrous in nature. Then more next to what, metals are good conductors, okay, good conductors of heat and electricity, right? So they are allowed to pass the electricity, means electric current through them, and heat also they are allowed to flow. So these are the lustrous and good conductors, like. And next they are also like malleable and ductile. What are they? They are called what? Malleable and ductile. What is the malleable and ductile? Malleable is what? Which can be made into the thin sheets. For example, if you have one metal, okay, and if you continuously beat with a hammer, so then you'll find that okay, it becomes a thin sheet. It becomes like a thin sheet. So it can be made into a thin sheet, that is called as the malleability. Ductility means water which can be drawn into the thin wires. It can be drawn into the thin wires. You can see the electric wires in that, you can see the copper wire will be there, right? So that metal can be drawn into the thin wires. So this is called a ductility. So these are the some of the properties of metals. And in already the last slide said that 118 elements are there. 118 elements are there. In that term, nearly 70% of elements are metals only. Okay, so we have total 118 elements. In that 118 elements, almost 70% of elements are metals. Clear? So can you give an example like metals? Gold, silver, sodium, potassium. Okay, these all are comes under the metals. Then come to the metalloids. Acha, before going to the metals, you can see the non-metals first. So what are the non-metals? Non-metals means which are not a metals. Which are not a metals. Like they are not sonorous, and they are not lustrous. They are not good conductors of heat and electricity. They are not malleable. They are not ductile. These all are comes under the non-metals, right? You can give an example like sulfur. This is a non-metal, and so many things you can give. Okay, that's a non-metals, right? And then come to the metalloids. Metalloids means what? Which have both the metallic and non-metallic properties. Metalloids means what? Which have both metallic and non-metallic properties are there. They are called as metalloids. They are not pure conductors, or they are not a pure bad conductors, means insulators, right? So such as metal elements are called metalloids. Example, we can see the silicon. Silicon, very important this one. So silicon and germanium we can give an example of metalloids, right? So silicon and germanium are examples for the metalloids. Then come to the noble gases. So in the non-metals actually comes gases also comes under non-metals only, students, like oxygen, nitrogen. These are comes under the gases, and gases are non-conductors because gases are generally not sonorous, they are not lustrous, they are not good conductors of heat and electricity, they are not malleable, they are not ductile, they are comes under the non-metals only. But here still we have a separate set of gases are there which are called as the noble gases. Okay, so these noble gases are the stable elements, like they are very considered. Total out of 118 elements, all the elements are not stable. In what basis they are not stable and stable, that we discuss in the later classes. So here noble gases, special set of gases are there, and those gases are noble gases which are like helium, okay, neon, argon, krypton, xenon and radon. These gases are considered as a noble gases, which are also called as a inert gases. Okay, inert gases actually especially they present for this property you can give for helium and neon only. Okay, now they are called as a inert gases and noble gas also. Why they are called inert gases, this also I'll explain in the later classes slowly. So these are the inert gases, and it means what? They are like they do not combine with the other elements, right? So here you can say, for example, that sodium can combine with the chlorine to form a sodium chloride. Hydrogen is there, hydrogen can combine with the oxygen to form water, right? Carbon can combine with the oxygen to form carbon dioxide. Like this, elements will combine with each other. This already we discussed, because we have only 118 elements, but compounds are some millions of compounds are there. Okay, so how? Because these elements will combine with each other, right? But here these are the gases are there which are called as noble gases, and these are stable gases. They do not combine with any other elements. Okay, why they do not combine with other elements? Because they are stable. Why they are stable? Because of their electronic configuration, right? So electronic configuration, I'll explain you. Don't worry, slowly, one by one, we go to the classes, right? So is this clear? Elements are classified into metals, metalloids, non-metals, and noble gases. Metals, all these properties: sonorous, lustrous, good conductors, malleable, ductile. And non-metals which do not have these properties as the non-metals. Metalloids, they have both metallic and non-metallic properties, are called metalloids. And noble gases, helium, neon, argon, krypton, xenon and radon are comes under the noble gases. Clear? Right? So here you see here list of common metals is given here. So here let's see the properties of metals and non-metals. Having some problem. Yes, students. So here you can see the properties of metals is given. Once you check the properties of metals here now. So an element is a metal which is having the following characteristics. What are they? It has a lustrous. Lustrous means what? Shiny. It's a good conductor of heat and electricity. Means they allow to flow the electric charge and the heat through them. Then come to the, it's a good, Then ductile. Ductile means what? Which can be drawn into the thin wires. Then malleable means what? They can be beat into the thin sheets. And they are solid at room temperature. And this I forgot to explain to you, that they have the melting and boiling point, high melting and boiling points, right? So it requires lot of temperature to melt or boil them, and they produce a sound, okay, when it is hit with the metals. So this is called as a sonorous. Sonorous means what I said, which are used to they produce a sound, right? So this is, and here some exceptions are also there for the metals. Mercury and gallium are liquid at room temperature. So you know that generally metals are solids. Metals means are solids generally. Okay, but there are few metals are there which are considered as metals, but they are not as solids. Like mercury and gallium. Very important. You need to remember this one. Mercury and gallium are the liquid metals at 30 degrees Celsius, and zinc is not malleable and ductile at room temperature. And sodium, potassium, calcium need to not have the high melting points. Okay, they are very soft, right? The first group elements which are there, like lithium, sodium, potassium, rubidium, cesium, francium, these are not much hard metals. Okay, this I will discuss in the later classes, right? So now this already we have discussed here. So these are the metals, right? Then come to the non-metals. Okay, then come to the non-metals. So here you can see the non-metals. What are the properties of non-metals? So these are the properties of non-metals. You can see, students, here. An element has a non-metal, so they are not lustrous, they are bad conductors, whereas the metals are good conductors, they are not ductile, they are the ductile and non-malleable, and generally these are the gases or solids at room temperature. They have the low melting and boiling points, and they do not produce much sound, right? And in this also some exemptions are there. Graphite. Graphite is called allotropic of carbon, students. Allotropic of carbon. I'll explain what is allotropy, right? At that time. So that we discuss allotropic form of carbon, but it's a good conductor of heat. Similarly, bromine is a liquid, non-metal, and iodine is a lustrous. Okay, it's a non-metal, but it's a lustrous. And some examples for non-metals are given. So these all are the examples for non-metal, like hydrogen, nitrogen, oxygen, fluorine, bromine, iodine, carbon, phosphorus, sulfur, and silicon. These all are the examples for the non-metals, right? Then we discuss the metalloids. Metalloids means what? Semi-metals. Semi means what? Half. Okay. Some properties of metals will be there. Some properties will be non-metals are there. They are called as the metalloids. So elements which exhibit some properties of metal and some properties of non-metals are called as the metalloids. So important metalloids we can consider silicon and germanium. Silicon and germanium are considered as the best means metalloids. Apart from this one, we can take arsenic, antimony, tellurium, polonium, boron, also some of the examples for the metalloids, right? Then come to the noble gases. I said you about the noble gases. Noble gases are also called as inert gases, and very few gases are there like helium, neon, argon, krypton, xenon, and radon. So these are the also called as the rare gases. Okay. So here you can see the list of noble gases: helium, neon, argon, krypton, xenon, and radon, right? So this is about the okay, this is about this one. Okay, and then come to the so this all we discussed, right? So today, let us. I'm going to give some important like how to write the formula. This already we discussed. No, symbol. Symbol is a representation of one molecule. If one molecule is how can we represent that? So symbol means what? The shorthand notation of the chemical substance or chemical compound is called as a symbol. For example, hydrogen is there, so we are representing the hydrogen with the H. That is a representation symbol. And so these are there. Here some list of important acids and bases also given here. Hydrochloric acid, nitric acid, sulfuric acid. But you should know how to write the formulas for this one. So these formulas will be explained in the next class to you. Okay. So, but you need to remember these are some important compounds which what we use in our normal days in the daily life. Okay. Hydrochloric acid, I think you might have seen in the laboratories. So in your lab there will be some chemicals there like acids, bases, and salts. So chemicals are mainly classified into three types called as acids, bases, and salts. The important acids are hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, carbonic acid, acetic acid, which is also called as a vinegar. So like this some acids are there. So here the list of some acids like hydrochloric acid, nitric acid, sulfuric acid. These are the acids. And there are some bases also there. Bases, I think already might have learned in the lower classes like 6th and 7th classes, there are the topics called acids and bases. Bases are what? Like sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide, zinc hydroxide, aluminum hydroxide, whichever end with the hydroxides, they are called bases. And of course, ammonia is also, it not end with the hydroxide, but it is considered as a weak base. Apart from, there are some salts also there. So salt means what? Normally we can say that sodium chloride is a salt. So now students, actually we have so many salts. Whenever one acid and base react with each other, then we can, okay, the salts are formed. So there are so many acids are there, you know, there are so many bases. So many acids and bases are there. So when they combine, they can form number of compounds. So they are all considered as a salts. Okay. So like, you know, salt, sodium carbonate is a salt. Sodium carbonate is salt. Why it is called salt? Because it is made from the acid and the base. Okay. Sodium means what? Sodium hydroxide. And CO3, carbonate, which is called carbonic acid. So it is made from one base and one acid, one strong acid, so a strong base called sodium hydroxide, where it's combining with a weak acid called carbonic acid. It forms a salt called sodium carbonate, and this is a salt. Okay, and here this salts, again there are three types of salts are there: neutral salts, acidic salts, and basic salts. We discuss later, don't worry. And see a salts example: sodium carbonate, sodium bicarbonate, which is also called sodium hydrogen carbonate, and ferrous sulfide, sodium chloride. These are common salt. Potassium nitrate, aluminum. These are all comes under the salts. Okay. So then come to the some common gaseous compounds. So these compounds, they exist in the gaseous state, like carbon dioxide. You know that carbon dioxide is a gas, right? And sulfur dioxide, hydrochloric acid, and methane, carbon monoxide, sulfur trioxide, nitrogen dioxide, and steam. Steam is nothing but a water, but it's boiled. After 100 degrees Celsius, then what happens? Water will be converted into the gaseous state. That's called as the steam, but it is in the, okay, gaseous state. So these are the common gaseous compounds, right? Now then come to the some metal oxides. So students, we are going to discuss, don't worry, we are going to discuss all how this forms also, how this magnesium oxide is formed, how zinc oxide, this all, and how to give the names, because for that you should know the valencies and you should know how to write the chemical formulas. After knowing the chemical formulas, how to give the names to these compounds also we discuss. So now, as of now, so you can see these are the metallic oxides. Metallic oxides means what? The oxides of metals. And you know the metals: sodium is a metal, magnesium is a metal, potassium is a metal, aluminum is a metal, zinc is a metal, calcium is a metal. These are the metals, right? So calcium oxide, zinc oxide, magnesium oxide, sodium oxide, potassium oxide. Okay, these all. So yeah, magnesium oxide, zinc oxide. So the oxides of metal are called as okay, metal oxides. Then the compounds of metals with the sulfur are called metal sulfides. So here some of the examples: magnesium when react with the sulfur, it forms the magnesium sulfide. Zinc when react with the sulfur, it forms the zinc sulfide. Lead is combining with the sulfur to form the lead sulfide. So whichever the metals they are combining with the sulfurs, what the product is formed, they are called sulfide. Like carbon is combining with the oxygen to form oxide, carbon dioxide, right? So sulfur, if it is combining, it's called sulfide, end with the ide, right? So these are binary compounds. Generally, whenever binary compounds are there, they end with the ide. Binary means what? Only two elements are there. Okay, like carbon dioxide, oxide, sodium chloride, chlorine, chloride, right? Fluorine, fluoride, iodine, iodide, nitrogen, nitride, sulfur, sulfide, like this. So whichever the binary compounds are there, that binary compounds, then we call, instead of their like chlorine, oxygen, nitrogen, instead of that, we say that chloride, oxide, nitride, sulfide, like this. So these are the sulfides, right? So this so students, now here so students, now based on this one, based on only elements and compounds, we have one exercise here. So this exercise you have to do, right? So exercise 1, so very simple and very easy exercise there. When you read this chapter, these topics, what I said, then you can answer these questions, right? So see now, elements are classified into metals, non-metals, metalloids, noble gases. Now, in this, which is correct? So this is called multiple answer questions, multiple answers, not only metals. So maybe 2 or more options are correct. So in the first option, you see 1, 2, 3 means metals, non-metals, metalloids only is there. Noble gases is not there. Is this correct? No. Let's go to the second one. 1, 2 and 4. 1 is metals, non-metals and noble gases. No, this is also not correct. 1, 3, 4. Metals, metalloids, noble gases. This is also not correct. Then fourth is what? 1, 2, 3, 4. Yes. Metals are classified into 4 types. Already we discussed that metals, elements are classified into 4 types. That already we discussed, like metals, non-metals, metalloids and noble gases. So the answer is first one is fourth one is the right answer. Right. Now let's come to the which of the following is the characteristics of non-metal? Non-metal. It's not a metal. So which of the following characteristics of non-metal? Non-metals. Whether they are lustrous or non-lustrous? Non-lustrous. Okay, next up to the bad conductor. Non-metals are the good conductors or bad conductor. For example, these are non-metals, it's not a metal. Okay, if I put in the electric wire, I'm connecting to this one and holding here. Can I get a shock here? No, because this is non-metal, right? So it's a bad conductor. Non-ductile, ductility means what I said, which can be drawn into the thin wires. Can you draw the thin wires? No. So the answer is all the above. Again, here 4 is the answer. So because all these are the characteristics of the non-metals. Which of the following is non-metal, but it's a good conductor of electricity? It's a non-metal. Generally, non-metals are bad conductors. No. But here this is a non-metal, but it's a good conductor of electricity. So what are there? Carbon in the form of graphite is given in the bracket. Nitrogen, fluorine, none of the above. So the answer is, students, graphite. Okay. The answer is graphite. So graphite actually it's an allotropic form of carbon. Allotropy means what? Existence of the same element in 2 or more different forms is called as a allotropy. Means one element only if it exists in 2 or different forms, more different forms. So that is called as a allotropy. In allotropy we are going to discuss later. So allotropy means what? Physical properties may be different, but chemical properties remains almost same. So here carbon actually exists in 3 main important allotropic forms, crystalline allotropic forms called the diamond, graphite and C16. And here diamond is a bad conductor, but graphite is a good conductor. So the answer is A means 1 is the right answer. Next, which of the following is a metalloid? Metalloid. Metalloid means what? Which has both the properties of metals and non-metals. That's called as a metalloid. So here polonium, helium, hydrogen, nitrogen. So nitrogen, hydrogen, helium are not. Why? Because these are the gases, right? So generally gases are not bad, they are bad conductors. Okay. So here polonium is a metalloid. So answer is 1. Now next one you see helium, neon, argon, krypton, xenon and radon are known as what? Trace elements, rare gases, inert gases, all the above. All the above. They are very minutely they are present in the atmosphere. So they are not present like they are not much more present in the atmosphere. We can get very rare gases. So they will be minute. Okay, in the very small quantity they are present in the atmosphere. So that's what they are called as a trace elements. And rare gases, inert gases. So we can call this and all the 3 names. So all the above is a right answer here. Right. Now, which of the following is a radioactive element? Students, here there are some elements of the radioactive. Radioactive means what? The element which dissociates by itself, which disintegrate. Instead of you can say dissociate, disintegrate. Which disintegrate by itself without any external force or pressure and releases some type of radiations. Such type of element is called as a radioactive element. For example, you know the radium. Radium is an example for the radioactive element. Okay. So in the periodic table, means what I said that 118 elements are there. All these 118 elements are arranged in one table, which is called as a periodic table. In the periodic table, elements are arranged in the increasing order of their atomic numbers. So the elements whose atomic number is greater than 83. Okay. Out of 118, whose atomic number is greater than 83. Means what? 84, 84, 85, 86, like, okay. Above all those elements are comes under radioactive elements. And here what are they given? Radon, neon, scandium, zinc. So radon is a radioactive element. Neon, scandium, zinc, neon atomic number is only 10 and scandium is 21, zinc is 30. Okay, so here the answer is radon. Radon is the right answer, right?